Okay, hello students. I would like to, in this video, I want to do a lot of practice problem on quiz 8. So some of you may have found it difficult to complete. So I'll walk through some of this problem. The first one here, use the calculator. So you're supposed to use the calculator to figure out what are these values, but they're given us what is hx. So this is what you need to put in the calculator, and then we'll feed this. Let's see. So the calculator is right here, and I'll start with the new one maybe. Let's start with new, and I want to calculate first. I want to make sure I'm using this. I want to store this function hx. So click on h of x. So you can just type in h parenthesis x, and then click on this one by first control and this, so that you can. That means you're going to store this, and you're going to put e raised to, so e raised to here, e raised to minus, so minus 3x, and you enter. So that is done. Now all you do is, the first question is asked h of 1/4. So put h and just put 1 divided by 4 and enter. But then the answer you won't get. So all you do is go back and click on Control Enter, so that you get decimal. You're supposed to write this decimal in three places. So right now this answer will be 0.472, because the 3 which is there, see, this 3 is less than 5, so I can just keep 472. So this answer will be 0.472, and likewise you can plug this in. Let me see how do I put this h of minus pi. So you put right here h of minus and then pi. So where is pi? Right here. So you can go right here also, control this one, and you can see pi is right here, and then control enter, and you get the answer. So this is what the first problem is. These are the some kind of problem that they can give. So this is problem number 1, practice problem for, again, I say, quiz 8. Let me do the second question. So the second question is, again, you need to use the graphing calculator, because this is, we don't know how the graph will look like, but it is y equals x times 5 raised to x. Okay, so, and then we need to know where is the function is increasing and decreasing, and we need to write the interval, decreasing interval, and what is the range. So all we do is go back to the calculator and start with the new page, and go to the graph and put x. So there is a x right here. So you can put x and 5 raised to. So it is 5, or you can say times 5 raised to the power. So go up and put x and enter. You can see. So now here, let me make it a little bigger. So we need to know where it is increasing and decreasing. See, the graph is going down. So all we do is, I'll try to take this one as maybe minus 2, maybe, so that we can see more of the graph. So there you go. And I don't want too much up, so this I'll make it 3. Okay, and there you go. So you can see there's a curve here, it's turning. So all you need to know is, so you can see this is decreasing. If you want to see more curve, we can still make this as -1. Let's see if I can make this -1. And there you go. So now you can see clearly. So all you do here is, we need to know until how low it goes. So we want to know that relative minimum here, because we want to know it is decreasing. So you can see from here, it's going on decreasing here, and there is a lowest one, it comes right here. So all you do is go, click on the menu, analyze, and then go to the minimum. So we want to know where the minimum here, also, and then the upper. And you can clearly see we got the point, and that's the one. So let me write here. So the graph here is using the red color. I can see this is decreasing till here, till here. So this point is this point, right? So till here it is decreasing. So decreasing in the interval. So all the way on this side is minus infinity. So minus infinity all the way to minus 0.621. And in the question, they will say how many places of decimal you want to write. So this will be two places. So if it is two places, I'll write 0.6 and 2. So no one here, just 0.62. If you put 1, your Cengage will not give you the right answer. So this is the where it is decreasing and then increasing. So increasing will be from minus 0.62. So now let me use the other color here, maybe the green one. So this one is increasing, going up. See, this is increasing. So that means everything to the right of this this 0.62. So from here to plus infinity, it is increasing. So this is the decreasing interval. This is the increasing interval. And what is the range part? See, so the range is the lowest it goes here is this is the lowest, and that is this part which is minus. I'm going to write here, this is 0.62 and the other one is 0.23 because of this 9 and you want to round it to the nearest two place. So this is the minimum, so relative minimum also, or local minimum, and that occurs at that point. So when you write the range, the lowest it goes is, so you have to use this bracket where you write 0, that's sorry minus, right? So this is minus, so that's minus 0.23 and then everything up here. See, so this is until plus infinity and you're done. So this is all they're asking you is first you use the graphing calculator to graph it, then you use the analyze tool to figure out the minimum, and then decreasing. You can clearly see from the graph it is decreasing here, this is decreasing and then increasing. So there is a point which is from decreasing to increasing. There's a local minimum here, a relative minimum, which is this number. So that's the relative minimum, and it occurs at minus. So this helps you to write the interval, and this helps you to write the range. And I hope that takes care. Let's do the third question. Question number 3 is graph the function not by plotting the point, but by starting the graph of e. So what is y equals e raised to x? Now remember, y is 2 raised to x, and then e is basically 2.7182 and raised to x, and y equals 3 raised to x. You have to know that if this is 2 raised to x, if this is 2 raised to x, and the 3 raised to x will be this will be e raised to x, and the 3 raised to x will be more steeper. So they all go through that. So this will be, so the blue graph is the one is the main focus for me, is that's the one is e. So this basically means it is e raised to x. So e raised to x. And then right now this is the main point, which is the 0, 1, and there is a horizontal asymptote. So this is the horizontal asymptote, which is the x-axis, and the equation of the x-axis is y equals 0. Now we need to know how this graph is. So you'll be given some choices there, and need to figure out what is the range maybe. And they may ask you what is the range, what is the domain, and what is the horizontal asymptote, all that stuff. So if this is the case, I want to do this hx. First of all, e raised to x. So this is e raised to. Then it changes to minus x, and then it changes to e raised to minus x minus y. So there are first part is this graph. So this is the graph. So this is the original graph, which is e raised to x. So this is taken care. Now, what does this mean is x is replaced by minus x. That means reflection over the y-axis. So that blue graph will now change to, it reflect over the y. So that means this will, so let me use red color. So this graph now will be something like this, something like this. So that's the e raised to minus x. And so let me take off the original one. We don't need. Now what is done? There is a minus 5. That means this graph, the red graph, has to be shifted 5 units down. That means if this is the 1, right? This is 1. So this is 0 and IIT 1, 2, 3, and 4. So this point will go 1, 2, 3, and 4, and 5. So this is how it will look like. So this will go till minus 4, and the horizontal x-axis. Let's use some different color. The horizontal, so this x-axis, this horizontal asymptote, that will also go down 5 places. That means it will go till here. So this will be the horizontal asymptote. So your graph will be using different color. Let me use nice color for that, pink color. That this graph will be passing this side, and that's how the shape of the graph is so beautiful. So this is that y hx equals. So so the domain is, if they ask you, the domain is everything minus infinity plus infinity. The range is, the lowest it goes is, see this part, this is y is minus 5, and that you can know directly from the number. So whatever this is, always the lowest it goes. So that means minus 5, the minus 5 is included, and then all the way to plus infinity. So you can see this is the lowest, closest it can go to, but doesn't, okay, I made a mistake. This should be round. You can't take, so this is round. It goes close to the equation y equals minus 5. So that's the range, and the horizontal asymptote is y is minus 5. You can see that's the one. This is the horizontal asymptote, which is y equals minus 5. I hope you understood this, how to go um, about not just sketching. So the pink color is this is the beautiful graph, which was, so the original graph, this is the original graph, gets reflected over the y-axis, and then it shift 5 units down. Okay, question number 4, practice problem. Express the equation in exponential form. So they give a ln of 7 is given. So this is 2y. And what does this mean? It is logarithm of 7 to the base e, because whenever you write ln, it is the base is e, and 2 raised to y. And then this is the base. I'm going to use, to change this to the exponential form, always start with the base. So e raised to, and the output. So this is the output here, and this is the input. So this output will be 2 raised to y equals, and the output, the input which is right here, becomes 7. That's all it is, and you're done. So all you're supposed to write here is e raised to 2y equals 7. And the other one becomes the same thing. I have to write e raised to, now it is minus 1. So this will be minus 1 equals t plus 8. And that's all you're going to enter in the box, like how you have this. So that takes care of question number 4. Let's do another one. So this is question number 5 is express the equation in the log form. So they already gave you in the exponent. So 7 raised to x equals 20, right? So when you write the logarithm, you may want to show this is the 7, which is the base that goes right here, and this is the output. So the output, and this is the input. So output becomes the input here, and the input becomes the output, and that's all you're supposed to write here. X equals log of 20 to the base 7, or you could also write log of 20, and make sure you put this parenthesis here. That's important. So this way, so this is the right way to write. Now the second one here, 7 raised to 9. So this one, the base is 7 there. Again, so I'll write logarithm of base 7. And the output is W. So it becomes the input of the log. And the 9, which is the input here, becomes 9 and you're done. That's all it is. Practice problem number 6 is using the definition of logarithmic function. So when I say definition of logarithmic means like log of, let's see, if we have log of e here and this is also e raised to p here, this is same as p times log of e to the base e, which is same as this is whenever this the base and the input is the same, the answer is 1, so you get the p. So in other words, if we have ln of e raised to maybe something p, in this case, it is as good as just writing p. Or also if you have e raised to ln of p, then also the answer is p. You get back the same thing. So now in this case, they give you this ln of x. This is given to you how to write. So ln of x, it means it is logarithm of x to the base e is 6. So all you do is you change this to the exponential form. So the base is the e. So the base e raised to, this is the output, which is become the input here, and the input x, that's the answer. So e raised to 6 is the answer. If you see this one, ln of e raised to, so this answer is straight away is same as writing 3 times ln of e, right? And what is this basically means? It is logarithm of e to the base e. And then whenever you have the base and the input is the same, remember logarithm of b and to the base b, this is always 1. So I'm going to use this as 3 times 1 is x. So x equals 1. So this answer is 1 and you're done. So even though we show this step, we can directly see if we have ln of e raised to p, remember it is just a p. Or if we have e raised to ln of p, then also it is p. So e and ln are inverse of each other. I just want to make sure we really understand this logarithmic thing. So remember, if I have b raised to x is y, then when you write the logarithm, it is log of the base is b, the output. So remember, this is exponential. So this is the input, and that's the output. So you just swap the output and the input. So this becomes the y, and the x becomes the output. So the output becomes the input, and the input which is right here, this becomes the x. And sometimes you can just remember it this way also. If we have b raised to x equals to y, and yeah, this is one way. Or you can also for this input, this is the value, right? So that way you can also use log of the value to the base b and x. Now we'll take simple example just in case. I don't know, I did not want to repeat this, but just wanted many of us, we forget. So 2 raised to 3 is 8, right? We know this. So when we write this in the logarithmic form, the 2 which is right here is put below here. The output which is 8 here is put as the input, and the input which is 3 becomes the output. So all does, what is this log basically means? How many times do you multiply the base? So just asking how many 2's do you have to multiply to go all the way to get 8? And you can say it is 1, 2, and 3. So there are 3 of them, see? And that's why we say 3 is the answer. That's all it is. So log basically means asking how many times do you multiply the base to get to 8? And it is 3 times. But there is a special when the base is, let's say, 10, and x could be anything here. Of course, x has to be greater than 0. So this kind of case on the calculator, you will see just log of x. It means this 10 you don't have to write. And another thing is that when the base is used So whenever I write logarithm of base is e is used, this is written as ln of x. So what this means is natural logarithm. So why natural logarithm? Because the base is used is e. Now where did this e come from? So the e is, this is because in the exponential form, let's see the exponential form hx, this is e raised to x. So e raised to x. And so the base is used as e, so we use it right here. And this e has a value which is an irrational number, 2.71821, and so on. So that's what this means. And then basically it is nothing but 1 plus 1 over x raised to x. If you put this on the calculator, you'll see this goes on. That's the value when x becomes, when x approaches a very large positive number, you will see this becomes like this way. So in other words, okay, I'm just trying to show this again. E basically means, what is that E? So on the graph, if you want to graph this function y equals like this, so you can't x cannot be 0. So so that means at 0. So when this is almost like so as x approaches a very small number close to 0 to the right side, that means this number will approach to 1. So there will be you can't, when x is 0, there's no output. So it starts like that and then goes on increasing, and maybe 2, and this is 3, and 2.7, 2.71. So there is a horizontal asymptote right here. So the graph approaches, see this part, this goes on increasing, and that number is called E. So this is what the meaning of that E. So that's how I just wanted to make sure you understand what is that E. Now, where did this E come from? There is a separate kind of a, I will just brief quickly here, because when you, the formula to compounding the money deposited, if P is the principal amount with some rate of interest per year, and you're compounding it n times, raised to, so how many times the interest is calculated is n times t. See, so this is the formula we know, but then we can, because there's r over n here, so this is r over n, so I'm going to use n. I want to divide by r and also multiply by r here. So this will be equal to p 1 plus rn, and I will try to write this as uh, n over r inside, and outside you can put this RT remaining. See this RT, and then in place of R over N, in place of R over N, in place of R over N, we can put 1 over N. So that means N over R will be N. So this whole thing becomes P 1 plus 1 over N, or you can put X also. So I can just put an X. This X. This becomes 1 over X divided raised to 1 over X, and then RT, and this whole thing is approaches to that E, which is 2.7182, and that's why that we write E raised to RT, and that's how the, when you want to compound, if you want to grow your money continuously, compounding it second, so this is that formula to be used. So that's how the E comes from. Question number 7 is just using the calculator, and you just have to click on ln of 8, and just, this is so simple. Only make sure you write it to 4-place decimal so that you don't make a mistake. Okay, here's the question number 8 here. Okay, now for this we need to know what is e raised to. So remember, what is ln of x and what is E raised to x, we know this is going to be e raised. Let's see, if this is e raised to x, then the inverse function of e raised to x is is reflection over the y equals x. So if this is 0, 1, then this has to be 1, 0. So the graph, this is the ln of x. So that becomes the function ln, the parent graph of parent function ln of x. In this case, they give us ln of x plus 3. So what that means basically means this graph which you see right here, this point. So I'm not interested to this one, so I'll take this off. And of course, and here you will see also there is a there is a vertical asymptote. So this is the vertical asymptote for the ln function. So what happened? So the question is asked, how does the graph look like, and what is the vertical asymptote they're asking you, and they also ask you what is the what else they can ask you is vertical asymptote and what is the domain and the range. Domain and the range. Okay, first of all, this graph, the red graph that you see is because of this plus thrust is shift 3 units to the right, 3 units to the left, sorry, to the left. So that means if this point is 1 and 0, this will move 1, 2, and 3. So this goes right here. And that pink color now, so this vertical asymptote now, this will go 1, it is through here, right? So it goes 1, 2, and 3. So this will be the red. Now it will be this one. So this is that at minus 3. It means x equals minus 3 is the vertical asymptote. Okay. And the graph will be, the new graph would be, I'll use the black color. So this red graph that you see, it will go something like this. Something like this. And that's all it is they asked. And of course, and the graph goes all the way down. So the domain is minus infinity till, of course, the domain, not the domain I'm talking about, the range is minus infinity plus infinity because it goes down and then goes up. But the range, the domain is at the most it goes extreme. So see this part, this is the domain. So this is the domain, goes to plus infinity, but to the left it goes until here. See this part? So minus 3. So minus 3 and plus infinity. And you're done. So the vertical asymptote is x is minus 3. And in order to really know how to find the vertical asymptote, suppose there was no graph and they just ask you this, all you do is you put this parenthesis, whole thing has to be greater than 0. That's how you do. That means it is x plus 3. And if you subtract 3, you get x. X is greater than, so the domain is this minus 3 onwards. So that's how you figure out. And x equals minus 3 become the vertical asymptote. So I hope this helps to understand. If the question was not asked about the sketching this is how you sketch it. If the question is just asked what is the domain, so over all you do is put the parenthesis equals to greater than 0 and then work it out. Also, now question number 9, similar type of question. The only difference is they give you it's the same thing. Remember the ln of x graph. This was the ln graph which passes through 1, 0. But because there is a plus 5 here, this goes to the left. 1, 2, 3, 4, and 5. So that means this is minus 4. So this part goes right here. And this is the y-axis is the vertical asymptote, which now will move to the left side. So it will go till here. So this will be the vertical asymptote, which is x equals minus 5. And you can see it is very easy to figure out a vertical by just changing this plus 5 becomes minus 5 there. and the graph will be this one. So the x-intercept. So what is the x-intercept? Is this one, which is negative 4 comma 0. So this is negative 4 comma 0. But what if they had not asked us this question and only asked us what is the x-intercept, and there was no in this there was no need of sketching, suppose. Then what you do, this is given to you ln of x plus 5. So you want to know when is the what should be this part, so that this is 0. Now we need to know, so when is logarithm of input is 0? Only when this part has to be 1, because we do know L of 1 is 0, or logarithm of 1 to the any base is always 0. So that means all you do is this, put the parenthesis x plus 5 equals 1, and then you subtract this and you get x equals minus 4. So this answer, which I put a box here, so now it is minus 4 comma 0, and this is how you figure out the x-intercept. I hope I made very clear. Remember, again I repeat, this is the original graph of the ln of x. This is ln of x. But because there is plus 5, shift 5 units, 1, 2, 3, 4, and 5. So this goes right here. And the vertical asymptote, in the beginning, this is the vertical asymptote, because the x has to be, when you talk about ln of x, it is greater than 0. But here, so it is minus 5 here. So the domain here will be, so the question is, what is the domain? I think they ask you the domain also. This part is taken care right here. And the domain is from starting with minus 5, but minus 5 is not included. So this is the domain like this. So plus infinity, and you're done. Question 11 is use the laws of logarithm to expand. Now, what is the meaning of expand? If you have m times n, it means you are writing m plus log of n. That's what it means. So the base is b, this is bb. This is called expand. So now you have, there are two parts here. It's logarithm of base is the 7, and so the m is like x, and the n is square root of y. So all we do, write is separately log of n plus log of 7, and the x is the first, and then root 7. Now root 7 can be also written as, so I'm going to keep the left side exactly the same. So this will remain the same. Nothing here. But this can be written as log of 7 raised to the power half. So the question is why? So remember, square root of b is always b raised to half. In other words, nth root of b is b raised to 1 over n. So, and then after that, you're applying another formula, logarithm of m raised to n and to the base b. This n gets multiplied outside, and you get a logarithm of m to the base b like this. So the half, that is, which is the power exponent here, that gets multiplied over here, and that's how you write log of this is 7. But when you have log of 7 to the base 7, that itself is 1. So your final answer will be like this, plus half times 1. And half times 1 will be plus half when you're done. I hope. Yes, my hand is paining, but still I'll do. I think the previous one was 9, and this is 10. Use the laws. Now this time there is a division. So if there is a division of the quotient, log of the quotient, then you have to write log, 2 log. But this time, instead of plus, you put minus. And those two, so this is that m, which you put 5x, and this is the n, which is y. See? But the left side itself is 5. It's a product of 2. So this stays the same, and this left side becomes log of 5 plus log of x. And this is how you expand it down. Make sure you put this in the parentheses. So this is the final answer. So how did we get this from here is I use this is like log of m. So that's what I did here, where m and n is 5 and x. Question 12 is about change of base. What is the meaning of change of base? It means suppose you have log b like this. We can always write this as 2 log up and down, but this time this a will remain up and this b base goes as input here, and you can write any new base here, c and c. Now that's it could be 2, 2 or 3, 3 or 4, 4 or 5, 5 down. In this case, we can write this as log of 5 up and log of 5, sorry, log of 8 and change it to maybe 3 and 3. Or it could be also log of 5 and log of 8. And you could also use 2 and 2. So it does not matter. And then in the calculator, let's see if I want to put this in the calculator. So, and you use the calculator and put, okay, log. So now we need to write two parts, up and down. I think I forgot what was it. Okay, so this is what I have to put log 5 and 8 to the base 2, right? So go back here and click quotient I want, right? So click on this in quotient and there I'm going to put this log. So log of 2 and put I think it was 5 or 8, whatever that you see. And down again you put log and again put a 2 there and put a 5 there. And then control enter and you want you to write 6 place decimal. So it is 1, 2, 3, 4, 5 and 6. So this will, so because the right side is 6, the 9 can be added 10 and then that will be 292030. So this is how you're supposed to do that problem. Okay, so I hope you understood this. 12, and let's see, I'm really tired. Okay, question number 13. Use the properties of log to rewrite and simplify. So let's see, we can, at the most, what can we do here? This is ln of 5 times e raised to 9, right? So this is of the form m, and this is n. So when you use log of m times n, this is same as log of m plus log of n. So this will be same as ln of 5 plus ln of e raised to 9. But then the second part, you have to write e raised to 9. So this ln of e raised to p is same as p straight away. So ln and, or in other words, just cross it out. That's what it says. So ln, or actually this exponent gets multiplied here. The right way to write is 9 ln of e. And ln of e basically means logarithm of e to the base e, which is 1. And that's why we say, okay, we just cross this out. And the final answer is ln of 5 and plus 9 times 1 and 9. So this is what you're supposed to put in the answer. Question 14 is asking us, this is question number 14, is which of the following interest rates and compounding periods would provide you the best returns when you deposit money in the bank? So we'll try to consider, let's see, you put $1 and also we'll put principal amount as $1 and also the T will put it is just for a 1 year. So the formula for this is A, the money that will be matured, the matured money will be the principal amount, whatever you have, 1 plus the rate R divided by how many times you want to compound in a year and N times T. So all I did was I took this as 1 and T also is 1. So your formula reduces to 1 plus R raised to N over N. Now, the first time you would need to know, it says 4% per year compounded monthly. That means your n is 12 here. Here n is 2 because semi-annually means in a year twice. So n is 2. And when you say compound means we have to use A equals P times E raised to R. So there is some change here where compounding we have to use this continuous. So first of all, let's plug this for the first one. We want to know which one is will give you good returns. So this will be T is 1. So this is what is important. And the first one, suppose I want to know this will be 1 plus, and what is 4/1/4%? Basically mean it is 4.25%. It means it is 4.25 over 100. That is 0.0425. So this will be 0.025 and divide by 12 and raised to 12. So this n is 12. So this is what you put in the calculator and see what you get. Second time you have second part is 4.5%, but that is semi-annually. So that means this formula now will be, so I write it here. It will be 4.5 basically means 4.5%, and which is 0.045. So I'm going to write here 1 plus 0. And then divide semi-annually n is 2 and put 2. So this you put on the calculator. And the last one is you write e raised to, because the dollar amount I took is 1. So for me you just have to write e. So this is the thing. So this is 1. So it is 1 times e raised to 4%. Now what is 4%? Means 0.04. So it is 0.04. That's it. That you just want to know what is this much. So these are the three parts. So I'm going to write up here. This is what you're going to write here. So this is the third one. This is the second one. This is the first one. Okay. And put yeah, all this. So each of these values, and we see which one gives you the highest, and that is the answer. So this you can put on the calculator and see which gives you the highest. So you just have to click which is the right answer.